M1 vectors, example 3. This isn't really like the questions that we get on the exam, but it's a really good way of demonstrating the principles of what's going on with vectors, and it's really useful for when you come to do Unit C4. We have a parallelogram, lots of different places on this parallelogram are labelled with letters. They've told us that OA, notice the arrow, is A. Now it's in bold when we handwrite it to show that it's a vector and not just a number or a variable. We have to put an underline. OA is the whole of this side here, and then OB, again, underline, is the whole of this side here. So we've got to express these other vectors in terms of A and B. So what you've got to say to yourself is, how do I get from O to C? Well, I'm going probably up here and along the top, or I could go along the bottom and up the side, various different routes. So write down the route you're doing. I'll do OA and AC. O to A is the vector A. We were told that in the question. And A to C is actually the same vector as O to B. It's in a different location, but it's the same length, it's the same direction, and so we can say AC is also B. Second one, AB. To get from A to B, I'm going to go A to O, and then I'm going to go O to B. Now, to go from A to O, you're going along the vector A, but the vector A goes upwards, and we're going downwards. So you put it as a negative. So from A to O is minus A, and then from O to B is the vector B. Let's label that on the diagram as well. And you could write that if you wanted to as B minus A. Next one, QC. Well, to get from Q to C, you could just sort of go lots of different routes, but I would just look at where it's positioned. It's going horizontally, and rather than being the whole side, it's actually half of the length of AC. And we know from earlier that AC is the same vector as OB, so we just write it as a half of B. Next one, CN. C to N. Going from C to N is the same as going from A to M, same vector. And we know what AM is because it's half of AO, half of this side going backwards down A, and so it's minus a half A. The last one, QN. So to go from Q to N, from here to here, I'm going to have a look at the parts of the question before, and I'm going to use those to help me. So to go from Q to N, I can go Q to C, because I've already worked that out. And then I can go from C to N. So from Q to N, I'm going Q to C and C to N. Q to C is a half B. C to N is minus a half A. And so you can write Qn as a half B minus a half A. And if you want to, you can factorise it, take the half out. That's sometimes helpful for these sorts of questions. It then says, what can you deduce about Qn? Well, I'm looking at Qn there. It's half of B minus A. I remember B minus A from earlier on. AB, A to B, was B minus A, and Q to N is half of B minus A. So what we can conclude is that Qn is actually parallel to AB because it's got a B minus A component, but it is half the length. And if you look at the diagram, that makes sense because if you look at where the vector AB is, and you look at where the vector Qn is, it's reasonable to see that those two are parallel, then perhaps that Qn is half the length of AB.